Yes, please go ahead, Doctor.
All right. Yeah. So, hi all. First of all, thank you to the organizers of Global Insights Conference of Artificial Intelligence for inviting me. This session focuses on LLM-powered application for contract compliance. Ensuring compliance of contracts have been a chronic problem for oil and gas regulators. This is because they need to ensure compliance of several hundred and in some instances, thousands of contracts. The oil contracts are long and often have multiple versions. This makes it humanly impractical to evaluate all these contracts in detail. Hence, an effective and accurate automated contract compliance application has been built to identify non-compliant contracts. This application is built using latest generative AI techniques. This talk aims to share methodology used to build this useful and effective application and its results. So we'll start with the business problem in hand, which is the compliance of contracts. Then we'll look into the data which we have explored, which is contracts in this case. Post that, we'll move to the methodology which has been adopted to build this application. Next section covers the key experiments which were run. Then comes the findings section. At the end, we can open the floor for questions. All right. As mentioned earlier, there are hundreds and thousands of active contracts at a point of time, which an oil and gas regulator managing, which specifically an oil and gas regulator managing large geographies like Europe needs to evaluate. Over and above the contracts, there are amendments, addendums, which change only few terms of the existing contract. While the existing contract still remains, essentially resulting in increase in the total number of documents. Detailed manual evaluation of hundreds and thousands of these documents is humanly impractical, as mentioned earlier. This results in selective evaluation, which exposes the oil and petroleum firms, the regulator, and the consumers in significant risk of several contracts remaining non-compliant. Objective was to build an useful and accurate contract compliance application which automatically identifies the contracts which are non-compliant. Also, the application identifies on which terms the contract is non-compliant. It makes it easy for the contracts team to find the defects in the contract and fix them. While initial objective was to build an application for contract compliance of oil and petroleum contracts, in short time, realization came that this problem of non-compliance is present in multiple industries and faced by Fortune 500 firms working in B2B space. Since they operate in B2B space, they have thousands of contracts with their customers and similarly with their suppliers. Hence, the application was made scalable so that it can be leveraged in several other industries like technology, healthcare, CPG, etc., where firms operate in B2B space. An accurate and automated contract compliance application can significantly reduce the risk of several contracts remaining non-compliant. It will be able to reduce financial risks in the range of few $100 million as well in some cases, protect companies' reputation, and so on. Okay, so let me stop sharing once. I will. We'll just look at a contract together. I know everyone would have looked at a contract. Has looked at a contract. It's just that we are trying to refresh our minds. I'll just wait for a second for the contract to come on the screen. And these are publicly available contracts from the website Resource Contracts. So this is a contract between Oil and Gas Authority, which is OGA, a regulatory body which is operating in Europe and sometimes outside Europe as well. Tangrim Energy, this operates so it's an oil and gas exploration company which operates in UK, some other countries in Europe, and even outside the Europe continent. This is a contract of around 37 pages. Most of the oil and gas contracts which I have seen are in the range of 30 to 120, 130 pages. Different terms, as you would expect in a contract, like grant of license, when the license was granted, term of license, from which initial terms. So they generally have an initial term, and that can be extended into second term. Initial term says for how long the initial term is there, and so on. Then you have amendments to the work program. As I said, amendments and addendums, if they change the terms, multiple terms significantly, several terms, then you will have a separate document. Otherwise, if just it changes 2, 3 terms, this minor change in the contract, then it just falls in the contract itself in a separate version. Surrender during initial terms, so things like various types of maps, the reports, the type of payments which has been made, the type of different types of accounts, etc., that needs to be submitted by the firm to the government. Extension of initial term to the second term. As I was saying, often after the initial term, there is a second term, option to continue the license into the third term, and so on. So these are different terms. There's a data confidentiality term. One term which is very important is the license area. The area quite often runs into several miles. In some cases, even touches 100 miles. So it turns very important to clearly capture in the contract the coordinates. So that's what is known as license area or block in the oil and gas contracts. That's very much there. So we just had a look at the contracts. Now let me again go back to the deck. So we looked at the business problem, we looked at the contract. Now let's look at the solution design. So through the solution design, the methodology used to build this application is also shared, and advanced retrieval augmented generation, which we often call as RAG. So it's a RAG-based LLM application, advanced RAG-based LLM application, which has been built. Retrieval augmented generation often is abbreviated as RAG. So I'll use the same abbreviation going forward. In standard RAG systems, external information is stored in a vector database. However, in this application, external information is stored in knowledge graph. Accuracy of identifying non-compliant contracts when knowledge graph was used was materially higher than when vector database was used. Hence, knowledge graph was selected instead of vector database. Contracts are complex, and it has several relationships, as often the terms of the contract are connected with one another. For complex textual data with several relationships, knowledge graph, as we know, are best suited to capture the relationships. So now let's look at the pipeline one. It has expired contracts which are stored in a Google Drive. Google Drive contains only the compliant portions of the expired contracts. There is manual detailed evaluation of the contracts, and only those portions of these contracts which are compliant are kept in Google Drive, because we wanted to create a database of compliant portions of the contract. These contracts are read from the drive when the LLMs have fixed context length. The contracts are split in parts. Post that, embedding models are used to convert these split portions of contracts into vector embeddings. This is a standard way we build large language models. Sentence transformers are used to convert these contract portions into vector embeddings. The vector embeddings are finally stored in a knowledge graph while maintaining the relationships between entities when they are getting stored. Hence, our knowledge graph holds the knowledge of how each of the terms should be written in a compliant contract. In other words, for a term like data confidentiality, the knowledge graph has all the points which should be covered from data confidentiality perspective. In pipeline 2, prompts are generated. These prompts check whether the required terms are present in the contract. The prompts are questions. For example, is the data confidentiality term completely present in the first split of the contract? Is it completely present in the second split of the contract, and so on? Due to the context length, remember in the pipeline when we have split the contract in different parts. The prompt has examples of the prompt has examples of all the points of data confidentiality which should be present in the contract. The prompt also says that if data confidentiality terms is complete in the contract, then respond as the term is completely present, else respond as the term is completely not present. In standard RAG, the prompt sent by user first goes to the vector database from where external information relevant to the prompt is retrieved. Then this external information is added to the prompt, and then the prompt, along with the retrieved external information, goes to the LLM to get the response which is sent to the user. However, in pipeline 2, instead of a standard RAG, there is self-RAG, and instead of a vector database, we have a knowledge graph. This combination of knowledge graph and self-RAG goes through multiple steps, which has multiple rounds of retrieval for the same prompt, instead of only one-time retrieval for one prompt, which is what happens in standard RAG. Multiple evaluations are done to check if response meant for the user is relevant and sufficient. There is evaluation at the beginning of the prompt, whether retrieval is needed or not. So self-RAG is more advanced. The most important thing about self-RAG is that it brings evaluation of what has been retrieved. It brings evaluation of the response which has been generated, whether it is useful and sufficient for the user. So there have been instances when retrieved documents are irrelevant and hence doesn't improve the accuracy and relevance of the LLM response. Also, it has been observed that some of the responses from LLM are partially correct or incorrect. In self-RAG, these evaluations are done in multiple points in the pipeline with the objective that the response provided to the user is more relevant and accurate. These evaluations are done by a separate LLM, which is also called the critique LLM. The main LLM which is used to generate the response to the prompt is known as generator LLM. Also, unlike standard RAG, which generates one LLM response per prompt, in self-RAG per prompt, multiple responses can be generated by generator LLM. Self-RAG does three separate evaluations, which we kind of talked about. First, whether the prompt is simple or complex. If the prompt is simple, retrieval is not needed. Second evaluation is it's a little different from the standard RAG systems or standard LLM, or rather it's different from standard RAG system. As we know from a RAG, when we are retrieving, multiple documents are retrieved. What happens in self-RAG is the top documents, each of those top documents get added to the prompt and then goes to the generator LLM and a response gets generated. So for multiple top documents which have been retrieved, multiple generated responses are created. And then there is an evaluation of these generated LLM responses. So suppose here we have mentioned 3 segments. They are further evaluated by the self-RAG to see which one is better. And the one which is considered the one which the critique LLM identifies is the better response out of the 3 segments, that one further goes through another round of checks through same critique LLM to see whether it is sufficient to answer all the different components of the prompt. If it is sufficient, it goes to the end user. If it is not sufficient, it goes through retrieval again. So now, let's in this section, let's look at the key experiments Experiments were done with multiple large language models like Llama 2, 7B Chat, Gemma 2B, etc., which are known to be efficient with question answering. Very large LLMs with higher than 7B parameters were not used due to so as to keep compute expenses within budget. Experimentation was done with standard RAG with multiple advanced variants of RAG like self-RAG, adaptive RAG, etc. Also, experiments included both vector databases and knowledge graphs. Oil contracts, as we mentioned, are complex, has multiple relationships between them, or it has multiple relationships between terms of the same contract, which gets better captured by knowledge graphs. Prompts were written thoughtfully. We kind of talked about that. The experiment results shared in this section are intuitive. So between prompting with no RAG and prompting with standard RAG, accuracy increases from 78% to 83%. Between standard RAG and self-RAG, accuracy further increases from 83% to 87%. Both Llama 2 7B chat and Gemma 2B provide similar accuracy of 87% in identifying non-compliant contracts when used with self-RAG. When vector database is replaced with knowledge graph, accuracy further improves to 91%. The final model selected was Llama 2 7B chat powered with self-RAG and knowledge graph. 91% accuracy was achieved with recall metric. 91% accuracy is in identifying non-compliant contracts is one of the highest accuracies recorded in literature. Also, not all non-compliant contracts or rather also not only the non-compliant contracts were identified, but the terms also which are not completely present were identified. It allowed the contract writers and the leaders present to know which term of the contract were incomplete and needed edits, else the contract writers had to go through the entire document in detail. So let's now move to the findings. We talked about the accuracy. The novelty of the solution which we have built is based on our knowledge graphs and self-RAGs have been used for the first time when it comes to contracts. And then when it comes to the accuracy, 91%, as I mentioned earlier, is one of the highest for contract compliance, which has been recorded so far. Okay. So in this view, here you would see that so some of the results, okay, some of the quantified results of non-compliance we are sharing in the results section. Accuracy we have already talked. For example, 0.5% of the contracts, the exact license area where oil company can extract or explore oil is not completely mentioned. Since these license areas are large, running into several miles, it's critical to mention the coordinates of the license area, as I was mentioning earlier. So what happens is that in some contracts, the coordinates are missing. Generally, all the terms are there in all these contracts because these are, they have significant value running into millions of dollars. What gets missed is certain portions of the term. Otherwise, overall, the term is there. In 2%, just as an example, in 2% of contracts, all the points of data confidentiality were not covered, which meant risks of data leakage, going outside the firm and the regulator body, going in the hands of the public. So now, even though the percentage of contracts which has issues with terms are low, given the high value of these contracts, non-compliance poses significant threats. Okay, with these with these results and findings, the session, the presentation now comes to an end. We are open to questions.